Hello friends, let us discuss one of the important aspects, that friction is the cause of the motion. And in general, we have already studied that friction always opposes the motion, but this is not true for every case. There are some exceptional cases in which the friction helps in the motion, or we can say the direction of the friction is along the direction of the motion. So we can say that friction not always opposes the motion of a moving body. So basically it means that in some cases friction is the cause of the motion, or we can say that the direction of friction is along the direction of motion, along the direction of motion. So we are going to discuss it in three cases. Let us call this as A, B, and the last one is C. Okay. Let us see case A. So from case A we can clearly see that the person moving is going to push the ground backwards. Okay, so it means it is going to give an action, and similarly the ground reacts and exert a forward force due to the friction which causes the motion. And here we are not in particular interested in what will be the magnitude of the action, because we can resolve it into two components and how the friction will be produced. It is much more convenient to remember that the force which we apply causes the action, and the correspondingly the ground reacts and produces a forward force due to the friction which causes the motion. Okay, so you can say that case 1, while moving, a person pushes the ground backward. Which we are going to call it as action. And because of this action, what happens? The ground reacts. And exerts a forward force. Due to friction. Which causes the motion. which causes motion. Okay. So therefore you can see that the direction of the motion is this way, the direction of motion, and we have direction of friction also in this direction. Okay. So they are in the same direction, direction of the friction as well as direction of the motion, because friction is causing the motion, so they have to be in same direction. And if we want to resolve this into two components, we can say this will be our action cos of theta and this will be action sine of theta. Okay. So friction will be, indirectly we can say, that result of the sine component of the action. So from here we can say that it is the friction which results in motion. The friction will result in motion. Therefore, the direction of friction and motion should be same. Okay, and from here we can also draw a small conclusion that if friction is 0, motion will be also 0. Okay, so we can say if no friction, then no motion. So this is the case A, but we have to remember here that if action is missing, there will be no reaction. Okay. So we can say that direction of motion and the direction of friction will be in same direction only if there is a presence of action. If action is missing, accordingly there will be no reaction, or we can say direction of the motion will not be same as the direction of the friction. Okay. From here we can say that the direction of friction and motion is same because of the action being generated by the force being generated by the push when person walk, or we can say run. This statement will be more, you can say, easily explained when we take case B. So in case B, we have two parts. Let us call this part 1 and this is part 2. In part 1, the cyclist is pedaling, and in part 2, the pedaling has stopped. So we can say in picture also the direction of the friction is going to change, and it changes only at one point where actually the force is being applied. Okay. So let us say case 2. In case 2, let us consider part 1. Under this part, force, you can say the cyclist is pedaling. So basically it means that as in normal cycling, the pedal is connected with the rear wheel. Okay? So you can say the rear wheel of the cycle is moved by the force exerted by the pedal. Pedaling. Okay. So this will be acting as this force will generate an action. This force will generate an action on the ground. By pushing it, okay, and this action is in backward direction. Okay, this action is in backward direction. So we can draw something like this. So if this is the wheel and it is connected with the help of a chain to a pedal, and this is the pedal. Okay, so this is the pedal and this is our wheel. The force is being applied, transferred from the pedal to the wheel, and accordingly what is going to happen, it is going to move in forward direction. That will be because of the friction, and this is our direction of motion. So here also you can say the direction of friction and direction of motion is same. Okay. Now this was in case of part 1. Part 1 means rear wheel. Okay, let me write it here. Part 1 means rear wheel. And now let us say part 2, which means front wheel. Now the front wheel moves independently. There is no such force acting on the front wheel. So this is our front wheel. Okay, and the front wheel moves by itself. Okay. So we can say front wheel moves by itself. So if you move itself, okay, So this will be the direction of motion, and this will be the friction. So front wheel moves by itself, therefore its direction of motion is toward right side, let us say right side, and direction of friction is toward left side. You can say direction of friction and direction of motion are opposite. We can say they are in opposite direction. Okay. So if direction of motion is this, towards the right, so we are going to have direction of friction toward left. Okay. But this happens when the force is being applied, or as we can say while pedaling. Okay. Especially in case of the real wheel. Okay. So this is, you can say, while pedaling. This front wheel, there is no relationship with the pedaling, it moves independently. That's why the directional friction and directional motion will be opposite side. Now let us consider case 2, or sorry, part 2, no pedaling. Okay. You can say case 2, part 2, no pedaling. Okay. So under this condition, there is no force exerted on the rear wheel. So there is no force, so there is action, is no action, we can say. Okay. Thus no action will be present because of the rear wheel. Okay. So this we are talking about only rear wheel. Okay. So because of that, rear wheel also moves freely or themselves. We can say independent of force. Because of that, the direction of friction, you can say the direction of friction will be opposite to the direction of motion. So for rear wheel now, this is our direction of motion. And this will be the direction of friction. Yeah, this is the direction of the friction. And the front wheel is still independent, so there is no change in the direction of the front wheel. From here we can see for front wheel there is no change. That is, direction of motion is opposite to direction of friction. Okay. So from here it is clear that as long as we are able to generate an action, then only the direction of friction as well as direction of motion will be in same direction. Otherwise, like in B second case, when pedaling stops, there is no action, and now the direction of motion as well as direction of the friction becomes opposite. Now this is case 3. There is this object is placed on a truck which is accelerating, okay, and this force of friction is the cause that the body moves along the truck, or the direction of motion is same. Okay. So let us say case C. So in case C, the body is placed on the truck which is accelerating, So now because of the force of friction, the body moves along the truck. Okay, or we can say the direction of acceleration as well as direction of friction is same. The direction of acceleration and direction of friction is same. But there is one condition which has to be fulfilled in order to so that they have the same. Okay, and the condition is that MA should be less than mu, let us say it is static, is given as mu s mg. If this condition is maintained, the body will be at rest, which basically means it will move along the truck. So these are three specific cases in which the friction is the cause of the motion. If in any of the cases the friction misses, if I can say if it's not present, then there won't be any motion. Okay. And there is a specific typical case while, especially for the cycling, while pedaling, the rear wheel has the same direction of the friction as the direction of motion, but as soon as we stop the pedaling, the direction of friction becomes in the opposite side to the direction of the motion. So this is an important concept specifically related to the friction which results in the cause of the motion. Now let us consider one question which is based on almost similar. An insect of mass m starts moving on a rough inclined surface from point A. As the surface is very sticky, the coefficient of friction between the insect and the incline is mu is 1. Assume that it can move in any direction up inclined plane or down the inclined plane. The maximum possible acceleration of the insect is. So this is insect A. The coefficient of friction mu is given as 1 and theta is 37. So we are going to find out what will be the maximum possible acceleration if it is moving in the downward direction or if it's moving in the upward direction. Okay. So let us consider that first part, it is insect is moving up. Up the inclined plane. So in that case, so this is 37 degree and this is the insect. It is moving up the inclined plane. Let us suppose with the acceleration A, and we are going can say this will be mg. It can be two per components. So this is 37, so this will be mg cos of 37 and this will be mg sine of 37. In the motion is up the inclined plane, so the friction, let us suppose it is Fr, will be also up the inclined plane and there is normal n. So we can say our Fr will be equal to mu n, and mu is 1 and n is our mg cos of 37. So we can say our Fr is mu is 1, we have mg cos of 37. You can say that direction of friction and direction of motion will be same. So if A is the acceleration, so we can write the equation as ma is equal to Fr minus mg sine of theta. We already know Fr, we have mg cos of 37 minus mg sine of 37, and this m cancels out, so we can say our acceleration a, taking g as common, is cos of 37 minus sine of 37. If you take g as 10, cos of 37 is 4 by 5, it is 3 by 5, so we can say our acceleration a is equal to 2 meter per second square. So this is acceleration of insect while moving up the inclined plane. Let us consider second part, when it is moving down the inclined plane. Insect is moving down the inclined plane. So it is moving down the inclined plane. So this is 37 and this is our insect, and it is moving down the inclined plane. Let us pose acceleration with a, and we can divide mg two components, like in first part this is 37, so this will be mg cos of 37, and this will be mg sine of 37, and we are going to have a friction Fr downward direction and the normal n. So these are the respective forces. We can say Fr is equal to mu n, and n is equal to mg cos of 37. Mu is given as 1, so Fr is equal to mg cos of 37. We can write the equation that ma is equal to Fr plus mg sine of 37. Put the value of Fr, we get ma is equal to mg cos of 37 plus mg sine of 37. M cancels out, we get a, taking g as common, cos of 37 plus sine of 37. Substituting the values, we get a 10, cos is 4 by 5 plus 3 by 5, so this will be coming as acceleration a will be equal to 14 meter per second square. So this is the acceleration of the insect down the plane. Acceleration of the insect moving down the inclined plane. So this completes the question as well as a little bit of explanation, which shows that the friction sometimes is also the cause of the motion. So under that condition, the direction of friction as well as the direction of the motion will be same. Thank you.